I said, today we're going to be talking about how to identify and draw compositions of transformations, such as implied reflection. I think we'll be okay with this. I'm going to move on. What is composition transformation? Well, it is when one transformation is followed by another. As an example, we have applied reflection, which is the composition of a translation and a reflection across a line that's parallel to the translation vector. Again, applied reflection. It is the composition of a translation and a reflection across a line parallel to the translation vector. Okay, Mr. Foster, in line reflection, what are the two transformations that take place? Translation and a reflection. Composition of transformations is when a single transformation is followed by another. That's why applied reflection fits that definition, right? Because that's a translation is one transformation, reflection is another one. Right on. Johnny Bravo. All right. Let's see here. Couple more seconds. Good, you got it. Good, you got it. Good, you got it. Myers. Get it right. Is he right or is he not right? Yes, sir. Where's he right? All right. We need to write this down. You come back. You can get it after. Okay. You need to write this down and you need to draw the diagram. The glide reflection that maps triangle JKL to triangle J prime, K prime, L prime is the composition of a translation along line B, followed by a reflection across line L. I'm sorry, I said line B. Vector B, followed by the reflection across line L. Yes, draw two. How many minutes? 6. Okay. Notice what happens here. On JKL, blue triangle, it's translated. What's translated mean? Let's try that again. What's translate mean? Slide. Slide. Or slides. With a lowercase f. Okay. It's going to slide which way? Left or right? Right. Right. Because you know why it's sliding right? See how vector B is pointed to the right? That's why we slide right. It's kind of simple, right? You follow the arrow, the way that the arrow is pointing. We keep it easy in here. And then it gets to that point, and it gets reflected across line L. After it's reflected, you got J prime, K prime, L prime. That is a glide reflection. We'll be drawing a few of these today. That was the drawings I say. Yes, ma'am.
I don't think that.
You know,
All right, guys. 10 seconds. Oh, yes. Did you get it all? Avery. Do it again. Go ahead, Josh. All right. 3, 2,
Why'd you get that first time, but you get
all right, make sure you write this down. What parts? The composition of two isometries is an isometry. Okay, then. Which means that the image after each transformation is converted to the previous image. All right, so here's the deal. Even though I've got a composition transformation, I'm dealing with two different types of transformations, each of which is isometric. Remember that word is isometry. It means when we move our shape, it maintains its size and its shape. Doesn't lose the shape, doesn't lose the size. Doesn't get bigger, doesn't get smaller. Flip it around, we can turn it, we can slide it, but the size and the shape stay the same. Then we have that word congruent. Who missed congruent last night? Somebody missed that question. I have one student missed it.
I don't know. I got it with me though. Oh wait, it was
Really, really, really close. It's not being congruent. Congruent means identical. Okay? All right.
Well, he's always done.
You right.
I do my part. I don't think I don't like it.
Maintain. Okay. How about I do this one? There we go. Okay. I'll do this one, guys. Draw the result of the composition of isometries. Triangle KLM has vertices K, L, and M. Rotate triangle KLM 180 degrees about the origin, and then reflect it across the y-axis. Got me? Yeah? No? Okay, let's talk. First thing I have to do is what? Okay, couple points. Got it. Next thing I have to do is what? Rotate. When I rotate 180 degrees. First thing, when I rotate 180 degrees, is to remember the trick involved in rotation. Oh man, it's going to be on your test. You're going to want to remember. Okay, here we go. Anytime I rotate, I take the opposite of x and the opposite of y. Write it in that order. If I rotate 180, I will take the opposite of 4, which is -4, The opposite of -1, which is +1. The opposite of 5, which is -5. The opposite of -2, which is +2. Opposite of 1, which is -1. The opposite of -4, which is 4. Let's plot those points, okay? I'll do it. You don't have to. -4, 1. -5, 2. -1, 4. That's cool. There is my 180-degree rotation. Right there. Next, what am I supposed to do? Reflect across the y-axis. When it says to reflect across the y, what's our trigger word that goes with reflect? Not fly. What? Flip, not fly. Flip. Okay. Flips. Flip with a little f. L-I-P. Okay. It could have an S depending on how it's used. I'm going to flip from here to here, over here, right? All I have to do when I flip across the y-axis will stay the same. I will take the opposite of the x that I'm working with. So here, I was at -4. Let's go back to +4x. 1 stays the same. I was at -5. Let's go back to +5. 2 stays the same. Here, I was at -1. Let's go to +1. 4 stays the same. I'll plot these points. 4, 1, 5, 2, 1, 4, and I have completed my composition of transformation. Here we have M double prime, L double prime, A double prime. Right? Take it in order, step by step. In order, step by step. Here are the steps. Rotate, reflect, and graph. Rotate, reflect, graph. Or translate, rotate, whatever it tells you to do, okay? I'm going to give you 2 different ones today to work with. You got me? Okay, let's see, let's practice. You guys write this down. I'll give you, we'll go 3.5 minutes to do the whole thing. Yeah, do the whole thing. Triangle JKL has vertices. J is at 1, -2, K is at 4, -2, and L is at 3, 0. Reflect triangle JKL across the x-axis and rotate it 180 degrees about the origin. What's the first, after I write down my coordinates, what's the first thing I'm going to do? What's the first transformation? Okay, flip it. Good. You saw reflect, you said flip. I'm fine with that. I'm going to flip it first, correct? Because reflect means flip. Flip it. And then I'm going to do what? Rotate it. Or turn. Okay? Flip it and turn it. Flip it and rotate it. it out, y'all. Reflect JLK or JKL across the x-axis. Point L, 3, 0. The x values will stay the same. Y values flip from negative to positive. The opposite of the y value. The opposite of 0 is still 0. It stays tight. Point J was at 1, -2. 1 will stay the same. The x value stays the same. -2 becomes +2. K was at 4, -2. 4 stays the same. 2, y value flips from negative to positive. Okay, there's J prime, here's J prime, there's L prime. Next, I take those values, the ones I just reflected, and I rotate them 180 degrees. Okay, remember, rotations start at XY, go -x, -y, right? -x to -y. Let's start with L. If I start at 3, 0, flip over here to -3, 0. If J starts at 1, 2, it goes -1, -2. K starts at 4, 2, it goes -4, -2. That's my 180-degree rotation. J double prime, I'm sorry, L double prime, J double prime, K double prime. Check the work. See how you did. Okay, that's how I would have reflected and then rotated. Reflect and then rotate. Got it? Don't work it today. Learn it, how to work it. Couple more seconds here. I got one last slide, I think. That's it. Cool. Ready? 3, 2, 1. Hi guys, I'm going to tell you what you need to write down. You write down this, and this. I want that part in your notes. First part. Composition of 2 reflections across the, the composition of 2 reflections across 2 parallel lines is equivalent to a translation. Okay, check it out. I reflect the blue triangle across the green triangle, and then I reflect the green triangle across to the red triangle. 2 reflections, right? Blue to green, green to red. Well, that's the same thing as if I had started with blue and I split it all the way to the red. Okay? Next. Why are you not writing this down? 1, 2, and 3. 2. The composition of 2 reflections across 2 intersecting lines is equivalent to a rotation. Okay? If I reflect blue to green, green to red, it's the same thing as if I had rotated blue to red. So that's how I get this theorem down here. Any translation or rotation is equivalent to a composition of 2 reflections. Okay? Any translation or rotation is equivalent to a composition of 2 reflections. So if I ever reflect twice, I could have either translated or rotated and got the same, let's just call it